Alright folks, our second video for this week is on exploratory data analysis. Now I know this chapter talked a lot about visualization. I wanted to touch on this first because I want you to think about visualization through the EDA lens. So what is exploratory data analysis? This is essentially the process of generating questions about your data and fine-tuning those questions. Your final is following an exploratory data analysis process where I ask you to play with data, come up with questions, and then try to visualize the answers to those questions. So in EDA process, 1, you generate questions about your data. 2, you search for answers by visualizing, transforming, and modeling your data. We're not going to get to modeling in this course, but that's what your subsequent DAX courses cover. And use what you learn to refine your questions and or generate new questions. It's a process. You say, oh, this is interesting about the data, I wonder. And then when you explore, you learn more and you adjust. The goal is to develop an understanding of your data. The idea is that you can't come up with a refined research question until you have a sense of what's going on in the rows and columns that you already have. So some foundation questions that you can use to help you come up with questions of your own is what type of variation occurs within my variables. So if there's a variable of education or whatever, like is there one education type that's way more prominent than others? Or what type of covariation occurs between my variables? Well, what is the relationship between two different variables? Again, I'm not expecting you to write a thesis. This is just what interests you in your data, what trends, what patterns can you see? So variation. Variation is the tendency of the values of a variable to change from measurement to measurement. It's essentially the behavior within your variables. So some questions could be which values are the most common and why? Which values are rare or unusual? Why? Does this match what you expect based on your existing knowledge? Are there any unusual patterns? What might explain them? Again, this is all about patterns and trying to see any overarching trends. Covariation is the tendency for the values of two or more variables to vary together in a related way. So think of correlation. It's a behavior between variables, and often you'll be able to visualize this relationship. Now again, we're going to cover visualization in depth next week, but this week I want you to start thinking about potential questions that you might want to explore for your final and with your data. So for example, I'm going to do a very basic exploratory data analysis on GSS 2022. You have this linked to, this is in this week's material. GSS is the General Social Survey data for 2022. This is a really, really common archive. People use the GSS data a lot, so you're probably going to see it in later DAX courses. And in order to come up with questions, what I do is I go straight to the codebook. So I look to the GSS codebook, specifically the section index of variables. The codebook is also linked, and I say, okay, I see there's lots of data. What are some questions that I might have? What is something that is interesting? And what pops out to me as a potential question between two variables is degree. So we have responses for these individuals' degree level, less than high school through graduate, and then also political views. So how do people rate themselves from extremely liberal to extremely conservative? And so a potential question that we could play with is, how do political views correlate to one's level of degree? This is the level of question that I want you to pick for your final. It doesn't have to be intense. Again, we're not doing a thesis level of work. We're just playing around with the columns we see to see what patterns can we learn. And then once I'm done with this portion of the lecture script, I also have an example called SNL example that will help you with this week's challenge. So let's go ahead to our code. First, let's see. What I'm going to do is show you this code book. I'm not going to scroll through all of it because it's hundreds and hundreds of pages long, but what I do is I scroll through and I get a sense of what questions there are. So I think it's on around like page 60 or so is where, can't be page 60. Somewhere in here we have the individual questions. There's lots and lots and lots of information about how this survey was conducted and who it includes. If you were to try to publish these results or you're refining your questions, this is all really helpful information to have. In the meantime, I'm just trying to see if I can find some trends between my columns. So this is what I scrolled through to find my particular questions. Keep scrolling, like we've got information about weighting. Again, we're not going to worry, but there is a survey research methods course that will be very helpful if you're interested in survey data specifically. Yeah, we see there's lots of different questions that we can choose from. I don't expect you to choose tons of columns. I just want you to isolate a few that are interesting to you. So that's what I've done. I scrolled through that code book and I said, okay, what if there's a relationship between education and political views? So here, what we're going to start with is reading in our data. So we've got GSS. You can see there's a year. It's all going to be 2020. Respondent ID, and then lots and lots and lots of survey questions. Let's get these two out of here. Okay. So we're going to do our little sanity check. Always great. Anytime you load data, read in data, especially for a Cordo document, make sure that you're running that head document, so that head function, so that way those that are reading your document can get a sense of what data is in it. And then dim, there's 3,544 survey respondents for 879 different questions or characteristics. This is a really big one. So again, I've looked through and I've decided that for this example, my variables of interest are degree and poll views. So one's degree level and then their political views. I'm also going to keep ID in here just because it's nice to have an identifier. So my basic research question, how do political views correlate to one's level of degree? What I'm going to do first is, because this is a huge data set, there's so many variables, I'm just going to select the columns that I want. And what's nice, because we're not editing the original data, because we're subsetting a new data frame, I can always go back and add in more columns if more variables become interesting to me. So we're going to select, we're saying, okay, I'm going to call this GSS degree poll views, GSS, then selecting ID, degree, and poll views. So here, we just keep those three columns and all of the different responses. And so I'm going to recode these values so they make sense. Again, this metadata is in the code book. That's what I'm basing it off of. I'm going to create a column called degree name where I have actual written out values. So rather than 0, 1, 2, 3, 4, which don't really mean anything to me at first glance, I'm calling them what they correlate to, which is less than high school all the way through graduate. And now note, I'm keeping the original column too, because we can still run descriptive statistics. We can run our mean, we can run things like this, but I like to have both. One is the numerical, and then one is our actual written out labels. So I've mutated two different columns here using case when, and now let's see. Now we have 5 variables. We have the original numbers, and then we have what I'm calling degree name and poll views name. I'm going to convert these variables into factors. The reason why I do this, and you're going to read this in next week's reading material, is because factors, when you make something a factor, you can order the way that it shows up. So less than high school makes sense to come before high school, or extremely liberal makes sense to come before liberal, and liberal should be between extremely liberal and slightly liberal, right? Like these have an order to them, and factors help us order them how we want them to be. So I'm automatically just going through and making these as factors because I know it's going to be helpful for me later. So degree levels, I have the levels for each of these, and then what I do is I just use the money indicator. So I say here is the data frame and the column. I use factor, the function factor, to designate these as factors with these specified levels. So here we go. Now when we take our head function, we look at our columns, we see that degree name and poll views name are both factors. So let's try to do some summary statistics. We can use summarize, like what we've done before. So range degree equals range poll, whatever. Go ahead and check through this. So I see that my range for degree goes from less than high school to graduate. My range for political views goes from extremely liberal to extremely conservative. So we've got folks all across the spectrums here. We've got mean values, standard deviations, and so forth. And what I think is important is checking the number of NA values. So there's no NA values for degree. Everyone answered that, but 118 people out of my several thousand did not answer political views. But rather than going through summarize, we could actually just use the SumStat function that we wrote above, and it's going to give us the same thing. Now, because I've cleared out things, I have to rerun this function. So remember from last video, I've created a function to calculate my various descriptive statistics. We can go back, and rather than rewriting all of that because we want the same thing, we can just run this. Now, I would need to edit that to add in the is NA column, but still, this is an example where functions can be helpful. If you have a particular set of descriptive statistics that you always like to run, write a function called sumstat, and there you go. You can just run it whenever you want with whatever data you like. So we're getting a sense of some of these values. And this is where I want you to be for the end of this challenge. I want you to think of a question and start looking at the descriptive statistics for the individual columns that you've chosen. Now, I don't expect you to accomplish the next steps until next week, but I want to show you what the next steps in exploratory data analysis are. So I've checked out, I've decided on some columns that I'm interested in. I've started to do some summary statistics. The next thing I can do is I can visualize. So here what I'm going to do is I'm going to use a bar chart to visualize the relationship between degree and political views. Excuse me. What I do first in this is I say, okay, GSS degree poll views, then we're going to subset everything that isn't an NA. So I don't want to have NA values. All I do is just subset. And this is important. This is why running some of those descriptive statistics can be important, because I know that there's NA values in poll views. Okay, so I'm removing them. Then I call the ggplot line. And so what this does is it says, hey, I want to plot these things. Aesthetics, X is my degree name. Fill is poll view's name. Fill is how I'm going to fill the bar chart. Then I'm going to say, hey, ggplot, I want this to be of bar chart type, and the position is going to be stack. I add in some labels, and then what this line does is it avoids overlapping text. So often in your horizontal axis, your x-axis, your text may overlap. This is a really easy fix. We just adjust the angle. And then I want to adjust the legend named to, rather than being poll name level or name or whatever it was, I want it to be political views. So those are the steps. And now this helps me get a sense of my question a little bit more. So we see here small numbers of people are extremely liberal, small numbers of people are extremely conservative, and it seems like the biggest chunk of folks that I have are those that have a high school education, and they are moderate. And so this is the idea of you visualize and say, okay, what are the trends that I see in my visualization? Another option that I can do is geom-tile. It's just a different type of visualization, and this is just following what your book did with both categorical variables. Here what I do is GSS poll views. Again, I open that, subset. I don't want the NA values in poll views. I'm going to create a count, so it counts occurrences with each variable. Then I'm plotting. X is degree name, Y is poll views. Geom-tile, and you'll see what that looks like in just a second. And I'm filling those tiles, X and Y, with the count. And then again, my labs, and we adjust the axis. And here, whoa, we see right here, moderate high school, it has by far the highest occurrence, right? So this is just a way to start looking at questions and start playing around with data. You could do whatever columns you want, come up with whatever question you want, and then the visualization will help you figure out trends. So let's go ahead over to our example for this week's challenge. So this example kind of pulls in a bunch of different things. We're going to go over joins, functions, a little bit of exploratory data analysis, and strings, because this week's challenge does have a section on strings. So as always, we make sure that we load our library at the very beginning, and then we're going to use 3 different files for this week's example. We have casts, actors, and seasons. And these are all SNL data. So we've got actors. Actors has the actor ID, their type, whether they're cast, and then their gender. Again, a lot of these data are problematic. They equate gender for sex. You'll see me use it sometimes interchangeably just because gender is the name of the column, but I do want to recognize that sex and gender are 2 different things. It's just one of the flaws in our data. Often they equate the 2. Casts has actor ID, season ID, and some other information. So some episode information, the number of episodes they were in. And then season has the years of the different seasons and the number of episodes. So let's check out the primary keys for each. You're going to be asked to do this in your challenge this week. So we're going to start off thinking through joins and functions. So in casts, I think that the compound primary key is going to be actor ID and season ID. So let's open up casts again. Casts, we have the actor ID. That's important. That's definitely one of them. But we see that the actors are listed in here a bunch of different times. That's because they're listed for each season. So the combination of these two is going to be our key, and the way, let me get back to the right code. The way we can check this is we can count and then filter to see if there's any counts where the same combination of aid and SID, which are again actor ID and season ID, if they pop up more than once. So we say casts, then count, then filter. Great. We have no examples where they come up more than once. That means that this is a good key. We also want to make sure that there's no null values, and yes, here again, we don't have any rows in this tibble. So good. I was correct. Actor ID and season ID work really well for keys. Same thing for actors and seasons. In actors, I think the primary key is that AID, the actor ID. I don't see any others. So we can go through, run the same steps, and we get two different tibbles that have 0 observations. That's great. Finally, same thing with season ID, and I'll tell you, none. Okay. But I just copied and pasted a bunch of code. And what if I just write a function instead? Now, obviously, we've only copied and pasted it 3 times, so it's not that big of a deal. But what if we had 10 different data sets that we had to read in? It's a lot easier if we just write a function. So I'm going to create a function called checkKey. And checkKey just combines the steps that I was repeating above. So I call it checkKey. I call function so that R knows that this is a function. And then I'm going to read in a particular data frame and the key variable. Now note, this particular function only works on single primary keys. It's just going to read in one because that's how I've set it up. So first, I open the data frame. Then I want to count. I want to count on that key variable, and then filter out anything where n, the count is assigned to name n, anything where n is greater than 1, or if there's an NA value on that key variable, I want to filter those out. So here we go. It follows the same exact logic of what we did above. I can check actors and their actor ID because I know that that's a column I think is the key. Great. Just like it did above, no rows, same thing with seasons. So we can run through all of the different data frames and columns. Now, if you're bored and you want to try a function, if you want to practice a function, see if you can write a function that checks compound primary keys. I'm going to leave that up to you if you're interested. It's not an assignment. But that's just an example of how we can think through functions of, okay, what is it that I'm feeding to the function and what are the steps that I'm doing over and over on different versions, different columns or different data frames, but I'm doing the same steps. But now we want to join the data sets. For a basic exploratory data question, I want to think through how have actors changed over time on SNL, and specifically, how has the gender composition or the sex composition of actors shifted over time? Another flaw in most data is they typically only recognize male and female as sexes. We know that intersex and other things exist, so I just want to acknowledge that, but yes, this is what we have in our data. So again, seasons has the season ID and the year, casts has the actor ID and the season ID, and actors has the actor ID and other information about the actors. So what I'm going to do is I'm going to use actors as my primary data. So I'm calling this first merge actors cast. I'm saying, okay, open actors, and then I'm using a left join. I'm joining actors and cast together by that AID column because actors has AID, cast has AID. It's a really great way to join these. So let's join. Whoops. Sorry about that. Click the wrong button. There we go. Let's join these. So we see actors cast. And then I always like to do a head function just to double check. And we see, good. We have actor ID, URL, type, gender. And then we also get in those season ID and things like that. Now, I want to merge this with yet another data frame. I want to merge with the seasons ID, because what I want is I want to correlate I want to match the season ID to the year that season is associated with. So we've got season ID and year. I want to merge that in because I want to see the gender of actors over time. So actors cast season, I'm just calling this very descriptive. These are all the data frames that I've pulled together. We're opening up actors cast using left join. They both have that season ID column. Here we go. And look at head. Now we have even more. And critically, now we have the actor, the gender, and the year and the season. So that's great. So now, I mean, there's a bunch of columns that I don't really particularly care about, so I'm just going to subset to the columns I'm caring about right now, which is actors, the actor ID, which is their name, their type, which is cast, that might be interesting, gender, season ID, and year. And you can always go back and adjust. If you think, hey, wait a second, this other column might be interesting, pull it in. Exploratory data analysis is all about just seeing what's interesting and seeing if you can track patterns in your data. Once you get out of the exploratory data analysis, that's where you want to do some research and go into the literature to determine specific research questions, but we're not there. And we won't be there for this course. That's your future courses. So for my exploratory data analysis, I'm curious, how does the sex composition of cast members shift over time? Essentially, are there always more men, always more women? Is it equal? Does it change? I'm curious, what are the trends? So the variables I'm interested in are year and gender. We're going to change that SNL year column to be of date type, just because it's a lot easier to visualize with it. And that worked, so I said SNL year, make date SNL year, and then I checked the class. Great, it worked, it did what I wanted it to. Now what I'm going to do is I want to check out the unique values in both gender and year, see if there's anything that's a little off. So I'm grouping by gender, and then I'm summarizing unique gender and unique year. Here I see two kind of strange entries. I've got Andy. Apparently Andy is a gender now, and unknown. That doesn't really make sense, so we're going to just move down to female and male as our analysis. And so what I'm going to do is filter out. I'm calling this SNL gender, and I'm filtering out any Andy or unknown examples. There was only one Andy and 4 unknowns, so we're going to filter those out of our data. And so let's see, did that work? Yes, it did. Now we just have 47 unique years and just female and male in our gender category. Great. So this is just like basic cleaning. Okay, let's remove NA values just for visualizations. Let's see what are the categories that we have. And so now what we're going to do is create a count variable. So I'm going to say SNL gender count. I like to always just name my data frame something super descriptive. We're grouping by gender and year. We're going to summarize n equals n. N is just a count, ungroup, and let's see here. Good. So we have what we want to graph, which is gender, year, and counts. So in 1975, there were 3 females. 1976, 3 females, and so forth. That doesn't change until 1980 when there's 6 females. So let's go ahead and plot. What we're going to do here is we open up that SNL gender count. We're going to again subset, make sure there's no NAs for the count values. Plotting, we know that we want to plot the year. We know we want to plot gender, and we also want to plot the count. So what I'm doing here is saying color equals gender. I want to use geompath, which connects observations in order. It's really great for time data. Scaling our x-axis, I went through and played with different options to scale the y-axis, just so that it made sense. And then, of course, our labels. And now we see, okay, here we have a preliminary answer to our data question. We've got, there's consistently more males, even though, there's consistently a gap between males and females on Saturday Night Live. Over time, there are more cast members overall, but this is just exploratory. We see, okay, yes, there's definitely always been more men than women here. And let's see, let's say I also am curious, okay, well, who's been on SNL the most? I can use, I can group by actor ID, summarize count, and then do the same thing. I'm not visualizing this just for sake of time, but we can do the same thing. We see that Kenan Thompson has been there the most. So if I wanted, some other questions could be in terms of the top showrunners, the top percentage. What's the gender composition there? Or what's the gender composition across different seasons, right? Like, we can play with different questions based on what interests you the most. Exploratory data analysis is really about what piques your interest. So now, just because this challenge does have a section on strings, I'm going to go through a few string examples for you. First and foremost, one thing that I think is really helpful to know is that you can create a column that just has the same thing. So for example, I am creating a column called show, and show is just populated with the word SNL or the string SNL for every entry. Now, the reason why this is valuable, I like to do this when I am specifically working with Reddit data. And so each data set that I pull comes from a different subreddit. But when I merge all these data sets together, I want to have an indicator of where the subreddit came from. So before I merge my data, what I like to do is, for each individual subreddit, I make a column called subreddit, and then I just populate it with whatever subreddit I'm working with. That way, in my giant data set, I can sort by subreddit, I can see if there's relationships amongst the subreddits. So this is just a helpful thing for you to do. This, I just mutate, I create a new column called show, it equals whatever I want it to be. In this case, I want it to be SNL. Let's say in the future, I wanted to do an analysis on Kate McKinnon. And so I can pull in data about Kate McKinnon from SNL and then maybe other companies or shows, right? It's just useful to be able to have this. Now let's say for whatever reason I'm curious about what SNL cast member has the longest name. This is just showing you how to use string detect because again it's one of our most useful functions in the stringr library. So what I'm going to do is I'm going to filter out. I decide that I only want it to be cast members. Our data does have different types of folks associated with the show. This question is just about cast members just because. So I just use string detect. I go on the type column and I detect cast. And then I'm going to mutate. I'm going to create a column called name no spaces. I'm removing all spaces from the AID column. So string remove all, I tell it the column, and then I say what I want to remove, which is spaces. If there were dots in your data or something like that, you can remove those. I'm also creating a column called name length, where I'm using the string length function on that name no spaces column. Then I'm just arranging in order of name length. What do you know? Julia Louise Dreyfus, I might be saying it wrong, I know who she is, I don't know how to say her name. She has the longest name length at 18 characters. Congratulations, Julia. Now, what if I'm curious about the string length distribution of like, okay, what does it seem, what length is the most common in terms of names? What I can do is do a very similar thing using the count function. Count length is string length. Here we have a range, and so I called that SNL name length. Look at that. We've got 2 n values with length 2 and so forth. Let's say I'm curious about the 460 names with 12 characters because that's the category that has the most entries. Let's see what those names are. SNL, then I filter where the string length of the actor ID is equivalent to 12. I count it, sort, and would you look at that? Fred Armisen is in there 11 times, Kevin Nealon 9, etc. Now, if I didn't want to have the duplicate names, I could just group by name. I don't need to for this because I really just wanted to show you count, string length, and string detect. So, last portion of this, let's say I want to know if someone is in the data set. So one of my favorite SNL skits is Pete Davidson's I'm Just Pete, based off of the Barbie movie, and I'm Just Ken. I love it. It's now stuck in my head, so it's going to be looping through for the rest of this video. So let's say I'm curious, is Pete Davidson in this data set? What I can do is I can say, okay, string detect on the SNL actor ID column. I'm using regex. I didn't go into much detail about this. This is the only one that you need to use on your own time. If you're interested, regex is a really complex and powerful way to manipulate and look into strings. For our purposes, I just want you to know the stringr functions, and you can use specifically regex here with the caret and the money sign to specify that you specifically just want this phrase. So I'm going to see, all right, is Pete in here? And if so, how many times? So I'm taking the sum. I can see that he's in here 7 times. Congratulations, Pete. Sum of how many times Pete Davidson has been detected. What about Zendaya? Is Zendaya in there? Do the same exact function. She's not. So she comes up 0 times. Let's say I do this for multiple names. You know, there's a list of 5 or so that you have to run through. Hint, this is on your challenge. You can instead write a function. So here, okay, these are the names that I'm interested in, Pete and Zendaya. I'm going to create a holder for name counts. So name counts is just what's going to pop up. For I in names, names being what I've specified here, name counts is going to be the sum of string detect of SNL and aid, just like what I've done previously. I'm just pulling that line in. If name counts is greater than 0, I print the name is in the data, else I print the name is not in the data. So for us, we have Pete Davidson and Zendaya. This function outputs this name is in the data because Pete is, and this name is not in the data because Zendaya is not. So that there's kind of a mashup of different things we've been going through. What I want you to know is, like, this is how you can work with these string functions. Exploratory data analysis is honestly, I think of it as fun, as, okay, let's see, what are the relationships, what are the patterns? For this one, for this challenge, I do not expect you to visualize, although you can take a crack at it if you want, that's totally fine. I just want you to think of some interesting questions that you could come up with for your data. And then, of course, here's more information on joining and functions. All right, that's it. Have a great week.